Hello students, and welcome to our first video lesson. And for this video lesson, we're going to be doing part 1 of section 2.7, which is covering parent functions and transformations. Now before we get started, I want you to take a look at this picture I put up of a parent and his child. And one thing we know about most parents and their children is that sometimes they share similar characteristics. Like if you look at this parent and along with the child, you can see that they share some similar characteristics. Like for example, they both have blue eyes. They also both have the same type of brown hair. You can also identify they have a similar smile. And also, they also have matching clothing. Though, of course, that's not true for all parents and children. Sometimes they won't have matching clothes, but sometimes they do. So the moral of the story is sometimes a parent and their child will share similar characteristics. And the same thing can also be said about functions. There's some functions that we'll look at that can be called parent functions. And if you have parent functions, there's also going to be child functions, which are going to be functions that will be very similar to the parent functions with just maybe a slight difference. And that's going to be the main topic for today, is looking at parent functions and their child functions. So on to the next slide, we'll see a more formal definition of parent functions, or in other words, a family of functions. So if I read this off, a family of graphs is a group of graphs that display one or more similar characteristics, like we explained in the first slide. The parent graph, which is the graph of the parent function, is going to be the simplest of the graphs in a family. And this is the graph that is transformed to create other members in the family of graphs. Or in other words, other members would be considered the child functions. So before we get started on describing child functions, I will introduce you to the 4 different types of parent functions. There will first be the constant parent function, the identity parent function, the absolute value parent function, it's ABS, absolute value parent function, and then there's the quadratic parent function. In the next 4 slides, we're going to go through each of these parent functions and see what they look like. Let's go ahead and get started. So the first parent function is the constant function. And it's called a constant function because every parent function that's a constant function will always be equal to a constant. Or in other words, it'll always be equal to a number. So you see in this graph is an example of the parent constant function y equals 1. And you can see right away that the one thing that makes the constant function easy to identify is that it's a horizontal line. And this is true for all constant functions. They're always a vertical line. Like say, for example, if I were to graph the constant function y equals -2. So I would go down to y equals -2. Basically start at the origin, go down 2, draw a horizontal line, and that's the graph of your constant function, y equals -2. So again, any constant function is always going to be equal to a constant, and the graph of a constant function will always be a horizontal line. So that one's the easiest to remember. The second parent function is called the identity function. And over here, the identity function is always going to be equal to y equals x. And the way to remember what the identity function looks like is that it is always a diagonal line whenever you graph it. And here's the interesting thing about the identity function. Let's take a look at all the points on this graph. Like, say, let's look at the point here. That's the point 1, 1. And then if you look at the next point, that's the point 2, 2. The next point, 3, 3. Here you have 0, 0, negative 1, negative 1, so on and so forth. And basically what you recognize is that every ordered pair that you look at is that their x and their y value is always going to be the same number. Or in other words, your x value will always be equal to your y value. Or in other words, 3 is going to be equal to 3, 2 is going to be equal to 2, so on and so forth. So if there's one way to remember the identity function is that the x and the y values will always be the same, just like its graph, its function describes. And its graph will always be a diagonal line. So that's the second parent function number 2. Now let's go to parent function number 3. This one is one that you've seen before back in our previous lesson, the absolute value function. In other words, if you remember our little catchphrase, absolute value has the V. Or in other words, value is equal to V. And of course, we say value is equal to V is because the absolute value looks like a V when you graph it. Don't really think I need to explain this one much more. This is probably one of the easier ones to remember. So that's parent function number 3. The last parent function is the quadratic function, parent function number 4. So its function always looks like f of x is equal to x squared, or as an equation, it's y equal to x squared. And its graph always looks like the U-shaped curve, which we call the parabola. And again, we've seen this one multiple times. This one's pretty easy to remember. And voila, that's the 4th parent function. Now, you go to the next slide. I went ahead and put all the parent functions all on one slide. Your constant function, your identity function, your absolute value function, and your quadratic. These are the 4 parent functions. And I recommend that you remember these and you remember these well, because these will actually be on a future quiz or test. And you will need to remember what these 4 parent functions are so that you can graph the child functions properly. So now, just a little quiz. Take a look at these three functions, and I want you to identify what type of function is represented in each graph. Or in other words, take a look at each graph and say, oh, this function must have the parent function, which is, well, I'll give this one as a freebie. This one looks like a V, so in other words, oh, its parent has to be the absolute value function, or the absolute value parent. So go ahead and pause the video, identify the next two graphs, look at each of these graphs, and identify what their parent function is. And once you identify them, start the video and we'll go over them. All right, welcome back. You should have identified the parent functions of these two graphs. So for this one, its parent function, if you look at its bell-shaped curve, that tells you right away that its parent function has to be the quadratic. And then if you look at the last one, we want to identify its parent. We look at it and say, oh, that is a horizontal line. And the only parent function that is a horizontal line is the constant parent function. And that's it. That's all I had to do. You just had to look at the graph and identify what the parent function of that graph. So that was the easy part. And now we are more familiar with parent functions. Now let's move to child functions. And child functions come from transformations. Transformations may be something that you've done before, either in Algebra 1 or in geometry. So hopefully this will be a review for most of us. So let me go ahead and read this. Transformations of a parent graph may appear in a different location, flip over an axis, or appear to have been stretched or compressed. The transformation or the transformed graph may resemble the parent graph, or it may not. So there's many transformations that we can work on, but the first transformation that we're going to talk about today is called a translation. And a translation is basically when you take a parent function and to create its child function, you're going to move it up, down, left, or right. So first, let me show you how to tell when a child function is going to move up or down. So when a constant k, or in other words, a number, is being added to or subtracted from a parent function, this is a translation of the graph going up or down. So basically, anytime you have a parent function and you're adding or subtracting a number from it, that's basically going to tell you that your child function is going to be moving up or down from its original parent function. So let's say I gave you an example such as, let's say I gave you f of x equal to x plus 5. So if you ignore the plus 5 for now and look at f of x is equal to x, you would say, oh, that's the identity parent function. And then the plus 5 tells you is that your child is going to be moving up 5 units. And then just another example, let's say I had the absolute value of x, and I'm subtracting 3 from that. you would say that the parent function would be the absolute value, because you see the absolute value bars and think, oh, well, yeah, that's the parent function. And then the child function, which is the absolute value of x minus 3, you're going to say the child function is going to be moving down 3. So in other words, if you add 5, or if you add a number, you'll move up, but if you subtract, you move down. So now let me better explain this in the next slide when we have to, by showing you how to graph it. So on the next slide, we have a graph, and at the top it says that we're going to describe the translation of the graph y equals the absolute value of x plus 2, and then graph the function. So the first step is we're going to take a look at this function, and we're going to ask ourselves, what is the parent? And of course, look at the absolute value of x. That tells us right away that our parent, I'm going to write over here that our parent is the absolute value, parent function. And let's go ahead and graph that. So we're going to start at the origin. And something I wanted to mention, every absolute value function, except for the constant function, always starts at the origin. So then the parent function, absolute value is a v, and that is our parent. But now we need to actually graph the child function, which is this entire thing. And looking at the plus 2, that tells us that, oh, since we're adding, that means we have to go up 2 units. So in other words, start at your parent function and just go up 2 units. 1, 2. We went up 2 units on the y-axis, and right at the point that we just drew, let's draw our V shape. And just like that, you have just drawn or graphed the child function, which shifted up 2 from the parent function. And that's all you have to do. Start with the parent function, identify if you're going up or down, and by how many units. And in this case, go up 2 units, graph it, and you have the child function. Or in other words, you have just graphed the function that we want. And that's all there is to it. If you look at the next slide, we see that's exactly what we just did. We identified the parent function, which was the absolute value of x, and then its child function has the similar characteristics of having an absolute value graph, which is, well, which is just the v. The only difference is that it went up 2 units from the parent function, just like that. So far, this is actually a pretty easy topic, as long as you just remember that adding 2 goes up and going down, or subtracting means going down. So let's do the same thing with this one. We're going to identify the parent function, and then we'll graph the parent function, and then we'll graph the child function. So looking at this graph, or looking at this function, y is equal to x squared minus 4, the x squared is our cue to say, oh, the parent is the quadratic function. So let's go ahead and draw the parent function. We'll start at the origin, and the quadratic has a U-shaped curve. And now the child function, we see here that we're subtracting, which means we're going to go down, and the 4 tells us that we're going to go down 4 units. So in other words, let's start at the origin and let's go down 4 units. 1, 2, 3, 4. So then this is going to be the bottom of the bell-shaped curve for the child function. Draw your U-shaped curve, and voila. You have your parent functions graph here, and you have the child function. Or in other words, this is the graph of y equals x squared minus 4. Just like that. So that's the easy stuff. Now, the last topic I want to cover is when to tell when a graph shifts left or right. Now, this is where you're going to need to listen up because this one's a little tricky. So, when a constant is added or subtracted from x before evaluating a parent function, this is a translation that goes left or right. Now, the thing I want to mention is if you looked at the previous graphs that we just graphed, or the previous functions that we just graphed, like for example, f of x is equal to x squared minus 4, we saw that the minus 4 told us that we were going to move down 4 units. However, what if the graph looked like this? Instead of the minus 4 being outside of the squared, but what if it was on the inside of the squared? Or in other words, it was inside the parentheses. And as it turns out, if you have this case where your number is being inside some sort of parentheses, that is actually telling you that you're going to be shifting left or right. So if it's on the outside, that tells you that you're going to move up or down. Or in other words, if your minus 4 is on the outside of your parent function, that's going to tell you if you move up or down. But if it's inside your parentheses or inside your power, that tells you you're going to move left or right. Now, and some of you may be thinking, okay, that's not too hard. If you basically, you're thinking, oh, that means if it's inside the parentheses and it's minus, that means I have to go to the left. And if it's plus, I have to go to the right. That's probably what most of you are thinking. And if you're thinking that, I am going to tell you to stop right there. Because when you move left or right, it's the opposite of what you think. So let me better explain. Let me erase these notes so I can get more space. So in other words, if you look back at that last function I showed you, and actually let me write that in blue. When I had x minus 4 squared, and all that inside the parentheses, you're probably going to think that the minus sign means that you're going to move to the left. But remember this trick. It's the opposite of what you think. So in other words, the minus sign inside the parentheses means I'm actually going to move to the right, not the left. Now the same thing is true for if I had, say, a plus sign on the inside of the parentheses. The plus would make you think that you're going to the right, but it's the opposite of what you think. It's actually going to be going to the left instead of the right. Now, if you remember that trick, when moving left or right, remember that it's the opposite of what you think. And you will have this basically mastered. So now let's use that technique with graphing. So again, we're going to take a look at this function. We're going to identify the parent function and then graph it, and then graph the child function. So looking at our original function, we see we have absolute value brackets. So that tells us right away that our parent function is the absolute value function. So we'll start at the origin. We'll graph our v for the absolute value function, and that is our parent. And now for the child function, for the child function, we see that the plus 3 is inside the absolute value. And if it's inside, that means we're going to have to move left or right. And since it's a plus sign, you would think it would go to the right. But remember, it's the opposite of what you think. You think it's going to go to the right, but it's not. So in other words, we're actually going to go to the left 3 units. So let's start the parent function. We said we're going to go left 3 units. 1, 2, 3. So in other words, this is where our child function is going to start. And then draw your V. And voila, you have your child function. And that's all there is to it. If you recognize that your plus or minus is inside the brackets or inside the parentheses, you identify if it goes left or right, and you do the opposite of what you think. Let's try that again with one more example. So this time we have y equals parentheses x minus 2. All that's going to be squared. Let's first identify the parent function. And the squared here is kind of a giveaway that it's going to be the quadratic parent function. So let's go ahead and graph that. Start at the origin. And we're going to go ahead and graph that parent function. And now the child function. To identify the child function, let's look at our minus 2. And we see right away that it's inside the parentheses. Or in other words, that means we're going to go left or right. And again, we see it's a minus 2. So you would think it would go to the left. But remember, it's the opposite of what you think. So it's not left, but it's going to go right 2 units. So start at the origin, move over 2 units to the right, 1, 2. And then from there, draw your parabola. And voila, you have your child function. And that's basically all there is to it. Identify your parent function and graph it. And for your child function, if anything's being added or subtracted on the outside of the bracket or parentheses, I'm going to put a 3 there. That means you're going to go up or down. If it turns out that your plus or minus is inside the bracket or parentheses, that's going to tell you to go left or right. And for left or right, it's the opposite of what you think. And if you remember that, this lesson will be a piece of, this part of the lesson will be a piece of cake. So here's the assignment. You can either do this on your own during the weekend, or you can wait until Tuesday to have some assistance. If you want, you can go ahead and get started, and then any questions you get stumped on, bring them to class on, come to class on Tuesday, bring those questions. I can help you out, and you can be done for the day. So 10 for 13, that's all you got to do is identify the parent functions. For 14 and 19, you'll be doing some graphing, where you'll graph the parent function and the child function. And you'll be using the graphing paper that I provided with the notes that I provided you. And with that, you are officially done, and I will see you next week.